Hello again, and welcome back to this quiet corner of the cosmos. I am so glad you have found your way here, to this place of rest and gentle curiosity. Perhaps the day was long and filled with noise, or perhaps your mind simply seeks a softer space to settle. Here, there is nothing for you to do but breathe. Let the weight of the world fall away. Let your body grow heavy and still, as if sinking into the softest starlight. Tonight, we will not journey far, not at first. We will begin at home in our own solar system, but we will drift toward its edges, toward the silent frontiers that separate our sun's gentle kingdom from the vast wild sea of the galaxy. We will float through invisible shields and wander among sleeping worlds, discovering the quiet, unseen architecture that holds our home together. Some of what you hear may be familiar, a whisper from a long-forgotten science class. Other thoughts may be new, sparks of wonder to light your path to sleep. And as always, there is no need to hold on to any of it. Simply let the ideas wash over you, like the slow, endless tide of space itself. Just before we begin our drift, if you find that these explorations bring you a measure of peace, a quiet harbor at the end of your day, consider liking and subscribing. It is a small, silent gesture that helps other weary travelers find their way to this place, one sleepy soul at a time. Now, close your eyes. Slow your breathing. Our journey to the quiet edges begins. Our solar system exists within a vast, invisible bubble. We think of our home as a collection of planets orbiting a star, a clockwork of gravity in the cold vacuum of space. But we are more sheltered than we know. Our sun does not sit silently in the dark. It breathes, and with every moment, it exhales a constant stream of charged particles, a current of plasma known as the solar wind. This wind, flowing outward in all directions at hundreds of kilometers per second, travels far past the orbit of Neptune, pushing against the galaxy beyond. It inflates a bubble, a great, magnetized sphere of influence called the heliosphere. This is the sun's true kingdom. We do not live in the open ocean of the galaxy. We live inside this warm, protective breath, a quiet haven carved out of the interstellar night. Every planet, every moon, every asteroid, and even you, resting here, are enclosed within this silent, luminous shield. This bubble is our first and final frontier, far beyond the orbits of the planets, at a distance more than 100 times that of the Earth from the sun. The solar wind begins to slow. It has traveled so far and spread so thin that it can no longer push back the galaxy with the same force. Here, it meets the interstellar medium, the thin gas and dust that drift between the stars. This meeting place is not a wall, but a long, slow conversation between two different realms of the universe. It is a boundary known as the heliopause. On one side lies everything familiar, the light and warmth and gravity of our own star. On the other lies the rest of the Milky Way, with its ancient cosmic rays, its magnetic fields woven by other suns, and the dust of stars that died long before our Earth was born. To cross it is to leave home in the truest sense, to step out from under the roof of our solar system and into the great open weather of the galaxy. It is a threshold of profound stillness, where the sun's whisper finally fades and the deeper silence of interstellar space begins. The shape of this shelter is not a perfect sphere. As the sun journeys around the center of the Milky Way, our entire solar system moves through the interstellar medium at an incredible speed. Because of this motion, the heliosphere is not a static bubble. It is drawn out, shaped by the galactic wind it passes through, much like a drop of water falling through the air. The side facing our direction of travel is compressed, forming a bow shock, a gentle ripple in space. The opposite side is stretched far behind us, forming a long, magnificent tail, a heliotail, that may extend for billions upon billions of kilometers. From a great distance, our home might look like a single glowing comet, a teardrop of light sailing through the spiral arms of the galaxy. We are not just sitting in a bubble, we are traveling within it. Our shield is also our vessel, a quiet, streamlined ship, carrying us on an orbit that takes more than 200 million years to complete. Even as you lie perfectly still, you are sweeping through the galaxy, enclosed in a soft, invisible flame that has been burning for billions of years. This bubble is what keeps us safe. The space between the stars is not empty. It is filled with cosmic rays, high-energy particles flung from exploding stars, and distant, violent events across the galaxy. These particles travel at nearly the speed of light, carrying enough energy to damage living cells and disrupt the delicate chemistry of life. But we are protected. The magnetic field carried by the solar wind, the very fabric of the heliosphere, acts as a shield. It deflects the majority of these galactic cosmic rays, turning them aside before they can ever reach the inner solar system. The bubble filters the universe for us. It softens the harshest radiation, creating a pocket of relative calm in the otherwise turbulent galactic environment. It is a quiet guardian, a vast, translucent wall that allows light to pass through, but holds the more violent whispers of the cosmos at bay. The peace we experience on Earth, the very stability that allowed life to arise and flourish, is owed in part to this immense, invisible structure, this gentle sigh of our star, holding the vast, chaotic galaxy at a safe distance, far beyond the last planet. Beyond even the sun's visible light lies the true edge of our solar system. Long after the rocky worlds have given way to gas giants, and the gas giants have faded into the icy twilight of the Kuiper Belt, there is a final, almost unimaginable realm. It is not a place of planets or even of light, but of a profound and ancient cold. This is the Oort cloud. It is not a cloud of gas, but a colossal, spherical shell made of trillions of sleeping comets, icy bodies left over from the formation of the solar system. It surrounds our sun and all its planets like a vast, frosty sphere, its inner edge beginning thousands of times farther from the sun than the Earth. This is the final reach of our sun's gravity, the last, faint whisper of its hold. We do not see it. No telescope can resolve these tiny, dark objects at such an immense distance. We know it is there only through its messengers, the long-period comets that occasionally fall inward toward the sun, ghosts from a dark and distant reservoir. The scale of the Oort cloud is difficult to comprehend. If our solar system, out to the orbit of Neptune, were the size of a small coin, the Oort cloud would be a sphere, the size of a great city, surrounding it on all sides. It is so vast that light takes more than a year to cross it. The space within it is almost perfect emptiness. The trillions of comets drift in a solitude that is nearly absolute. Each icy world is separated from its nearest neighbor by tens of millions of kilometers. They move with incredible slowness, taking millions of years to complete a single lazy orbit around the distant sun, which from there appears as nothing more than an exceptionally bright star, its warmth utterly lost to the immense distance. It is a realm of utter silence, of a darkness deeper than any night we have ever known. Here time itself seems to move differently, measured not in days or years, but in the slow, patient turning of eons. These are the forgotten children of the sun, drifting in the great dark, waiting for a call that may never come. These icy worlds are fossils of our beginning. They are not strangers. They are family. The comets of the Oort cloud are primordial remnants, the leftover building blocks from when the planets first formed, some 4.5 billion years ago. In the chaotic youth of the solar system, the immense gravity of the young giant planets, Jupiter and Saturn, acted like cosmic slingshots. They gathered up countless small, icy bodies from the inner solar system and flung them outward into these distant, stable orbits. These comets are therefore time capsules, perfectly preserved in the deep freeze of interstellar space. They carry within them the original chemistry of the nebula from which our sun and planets were born. They are the quietest archives of our solar system's history, holding the story of our origins in their frozen hearts. When one of them is nudged from its long slumber and begins its journey inward, it brings with it a message from a time before Earth, before life, a whisper from the dawn of our own world. A gentle nudge is all it takes to awaken one. For billions of years, these comets drift in their silent, stable orbits, undisturbed. But the galaxy is not entirely still. Occasionally, a passing star may drift close enough for its gravity to send a faint ripple through the Oort cloud. Another source of disturbance could be the great gravitational tides of the Milky Way galaxy itself, which flex and stretch this vast sphere of comets as our solar system orbits the galactic center. This gentle cosmic nudge, a whisper of gravity across light years, is all that is needed to disrupt a comet's delicate path. Its orbit may be altered just enough for it to begin a long, slow fall toward the inner solar system. This is not a sudden plunge, but a journey that can take millions of years to complete. It is a slow, patient return from exile. As it draws closer, the distant sun grows brighter. Its warmth begins to stir the ancient ice, and the sleeping world awakens, growing the beautiful ghostly tale that we see as a comet in our night sky. Each one is a visitor from the deep, a messenger from the edge of darkness, reminding us of the vast, cold, and silent realm that encloses our small, warm home. And yet, a messenger from our world has already crossed that silent border. Two, in fact. They are the Voyager probes, tiny drifting vessels launched in a time before many of us were born. For decades, they flew outward, past the great colored storms of Jupiter, past the ethereal rings of Saturn, beyond the pale blue stillness of Uranus and Neptune. They continued on into the vast, empty territory where the planets cease and the sun's light is just a faint, distant glow. They traveled through the quiet, unseen architecture of our home, and then, one by one, they left it. They passed through the heliopause, the final, shimmering edge of the sun's breath. The familiar breeze of the solar wind at their backs fell away, replaced by the thin, ancient breath of the galaxy itself. They are now swimming in a new ocean, the space between the stars. These tiny emissaries are now the most distant objects ever made by human hands. They are so far away that a command sent from Earth, traveling at the speed of light, takes nearly a full day to reach them, and their faint reply, a whisper of data across the void, takes another full day to return. They are unimaginably alone. The silence they experience is absolute, a quiet that has existed for eons, broken only by the faint hum of their own aging electronics and the occasional patter of interstellar dust. The sun, from their perspective, has shrunk to a brilliant point of light, the brightest star in a sky now crowded with unfamiliar constellations. They are no longer truly part of the solar system. They are the first true interstellar wanderers of our own making, two specks of human thought drifting in the great galactic river. Each of these silent pilgrims carries a message. Bolted to their sides is a golden phonograph record, a time capsule of sight and sound from a small blue world. It is a message in a bottle, cast into the cosmic ocean. It carries greetings in dozens of human languages, the sound of wind and rain, the cry of a newborn baby, the rhythm of a human heartbeat. It holds music, from the intricate patterns of Bach to the deep, soulful call of the blues, a collection of lullabies for the stars. It is a portrait of who we were, in a fleeting moment of our history, offered up to the vast, unknowable future. The chances of it ever being found are infinitesimally small. It is not truly a message for anyone else. It is a message for ourselves. It is a testament to the fact that on a quiet world, in a distant spiral arm, a species emerged that looked up at the night sky and felt such a profound sense of wonder that it reached out, not with a hand, but with a song. The journey of these probes reminds us of time. They travel at astonishing speeds by human standards, more than 15 kilometers every single second. Yet the galaxy is so vast that even at this pace, it will take them 40,000 years just to pass near another star. Their power sources, fueled by the slow decay of radioactive elements, are now fading. In the coming years, their instruments will shut down one by one. Their faint voices will fall silent. They will cease to be our eyes and ears in the void and will become something else. They will become ghosts, silent, drifting artifacts, carrying the warm memory of a world they can never return to. They will drift on, cold and dark, for millions, perhaps billions of years, orbiting the center of the Milky Way along with all the stars. They may outlast mountains on Earth, outlast the continents themselves. They are a quiet act of faith, a piece of our soul given over to eternity, a silent promise that for a brief moment we were here and we wondered. Even as our messengers drift away into that endless night, there are hints that the map of our home is still incomplete. We look to the farthest, coldest edges of our solar system, to the realm of the Oort cloud, and we see something strange. Out in that deep, frozen twilight, far beyond the orbit of Neptune, there are dozens of small, icy worlds, objects no larger than small moons, tracing out immense, looping paths around our sun. For years we thought their orbits were random, scattered by time and distance. But when we mapped them, a pattern emerged. These distant worlds are not scattered at all. They are clustered. Their long, elliptical orbits all swing out in the same general direction, tilted at the same angle, as if they are being shepherded. It is as if a great, unseen hand is gently organizing the very edges of our solar system. The most likely explanation for this quiet order is a ghost, a planet, a massive, hidden world, 5 to 10 times the mass of the Earth, lurking in the profound darkness of the outer solar system. This is the Planet 9 hypothesis. It suggests that our solar system has another major member, a world we have never seen, whose gravitational influence is the gentle, invisible hand guiding those distant, icy bodies. It would not be a world like Earth or Mars. It would be a cold giant, perhaps with a thick atmosphere of hydrogen and helium, a small cousin to Neptune or Uranus. It would orbit so far from the Sun that its year, the time it takes to complete a single loop, would last between 10,000 and 20,000 Earth years. It is a heartbeat on a scale of time we can barely imagine, a slow, deep breath taken over the course of human civilization. We have not seen it because it is almost perfectly hidden. At such an immense distance, the Sun would appear as little more than a brilliant, searing star, its warmth utterly lost to the void. This world would be locked in a perpetual, deep twilight, its surface temperature hundreds of degrees below zero. It reflects almost no light. It is a phantom, a black pearl floating in a black ocean. Searching for it is like trying to spot a single piece of coal in a vast, dark field on a moonless night. Astronomers are hunting for it, scanning the sky for a pinprick of light, moving impossibly slowly against the backdrop of distant stars. It is a patient, quiet search for a shy and distant giant, a world whose presence we feel only through the faint gravitational echo it leaves on its smallest, most distant neighbors. Where would such a world come from? Perhaps it is a native of our solar system, a sibling to the other planets that formed alongside them, but was flung into this distant, lonely orbit by a gravitational encounter in the system's chaotic youth. It would be an exiled member of our family, a long-lost prince living in the cold wilderness. Or perhaps it is an immigrant, a rogue planet that was born in orbit around another star and wandered through the galaxy alone for billions of years. In a chance encounter, it may have drifted too close to our sun and been captured by its gravity, settling into this vast, tilted orbit. If so, it would be a true stranger in our midst, a visitor from another solar system that has become a permanent, if hidden, part of our own. Either way, its existence would reshape our understanding of our home, reminding us that even after centuries of looking, our own backyard still holds mysteries as deep as any in the galaxy. Imagine what it would be like to be there. Imagine floating in the darkness of its orbit, a quiet observer in that immense cold. The Milky Way would stretch across the sky, not as a faint, hazy band, but as a brilliant, glittering river of light, unobscured by any atmosphere. A torrent of starlight, dense and bright. The familiar constellations would be gone, lost in the sheer number of visible stars. And against this breathtaking backdrop, the distant sun would be just a single dominant star, its family of inner planets entirely invisible. You would be in our solar system, but you would not feel at home. You would feel as though you were on a lonely ship, moored at the very edge of a vast, luminous harbor. Looking back at a single, distant beacon, the existence of this world is a whisper, a hypothesis born from patterns in the dark, but it speaks to a fundamental truth of the cosmos. The universe is not always what it seems. Its most powerful forces are often silent, and its greatest treasures are sometimes hidden, waiting patiently in the quiet dark for a curious eye to find them. As we drift back inward from those cold, hypothetical frontiers, we return to the more familiar realms of our solar system. But even here, among the worlds we have studied for decades, lie secrets hidden in plain sight. We look to Jupiter, the great king of planets, a swirling behemoth of gas and storm, and in its orbit we find a family of moons, tiny points of light circling the giant. One of them, Europa, looks at first like a simple ball of ice, its surface a fractured, off-white canvas of cracks and ridges. It is bright, reflective, and seemingly frozen solid. But beneath that silent, icy shell, something extraordinary is hidden. There is an ocean, not a small trapped pocket of water, but a vast global ocean of liquid salt water wrapping the entire moon. This is not a guess. It is a near certainty. The evidence is written on Europa's face. The great, crisscrossing lines on its surface are like the patterns of sea ice in Earth's Arctic, suggesting a solid crust floating on a liquid interior. We see areas where the ice appears to have broken apart and refrozen, like great ice flows drifting on a hidden current. And most tellingly, a faint magnetic field has been detected around the moon, a field that changes as it orbits through Jupiter's powerful magnetic field. The best explanation for this is a deep layer of something electrically conductive, like a salty ocean, hidden beneath the ice. The moon is flexing. As it orbits Jupiter, the immense gravitational pull of the giant planet rhythmically squeezes and stretches the little moon. This constant tidal flexing creates friction deep within its core, generating enough heat to keep a vast hidden ocean in a liquid state, despite a surface temperature cold enough to freeze nitrogen solid. The scale of this hidden world is staggering. The ice shell is thought to be many kilometers thick, perhaps 10 or 20, but beneath it, the ocean may be more than 100 kilometers deep. If this is true, then this one small moon, smaller than our own, contains more than twice the amount of liquid water found in all of Earth's oceans combined. Imagine it, an ocean of utter darkness, untouched by sunlight for billions of years. An ocean under immense pressure, its floor a landscape of rock and silence. Down in that eternal night, at the boundary between the water and the rocky mantle below, it is possible that there are hydrothermal vents, fissures in the seafloor, spewing out heat and chemical nutrients from the moon's interior, just as they do on Earth's ocean floors. On Earth, these vents are oases for life, entire ecosystems that thrive in total darkness, powered not by the sun, but by the chemical energy of the planet itself. Could something be alive in Europa's dark, secret sea? We do not know, but the ingredients are there. Liquid water, a source of energy, and the necessary chemical building blocks delivered by comets and asteroids over billions of years. If life exists, it would be utterly alien to us, a form of biology born and evolved in a world of cold, darkness, and pressure. It would know nothing of stars or sky. Its entire universe would be the water column. Its only light, the faint, ghostly glow of chemical reactions on the seafloor. It is a thought that is both thrilling and deeply humbling. One of the most promising places to search for life beyond Earth is not on a warm, sunlit surface, but in the cold, black heart of a tiny frozen moon, in an ocean that we can only imagine, an ocean that has been waiting in perfect silence for billions of years. And Europa is not alone in its secret. We journey outward again to the magnificent realm of Saturn, the ringed jewel of our solar system. Here, among its own vast family of moons, we find a tiny world called Enceladus. It is small, barely 500 kilometers in diameter, so tiny you could fit it inside the borders of a single large state on Earth. Like Europa, it is covered in a shell of bright, clean ice, reflecting sunlight like freshly fallen snow. It seems a quiet, simple place. But Enceladus is not sleeping. It is alive. From great fissures near its south pole, enormous plumes of water vapor and ice particles are erupting continuously into space, like a collection of cosmic geysers. These plumes shoot hundreds of kilometers out from the surface, a fine, glittering mist that freezes instantly in the vacuum, contributing to the faint E-ring of Saturn. The moon is actively breathing its own ocean out into space. This is not a relic of the past. It is happening right now. The Cassini spacecraft, in one of the most daring feats of its long mission, flew directly through these plumes. Its instruments tasted the spray. It found water vapor, tiny grains of silica sand, and complex organic molecules, the very building blocks of life as we know it. The presence of silica sand is a smoking gun. It suggests that deep beneath the ice, on the floor of a hidden ocean, there are hydrothermal vents operating at temperatures of at least 90 degrees Celsius. Hot water is dissolving minerals from a rocky core and spewing them up into the ocean, a process identical to what happens in Earth's deepest seas. Enceladus, a tiny snowball of a moon, has a warm, chemically rich, saltwater ocean hidden beneath its ice, and it is actively telling us about it. The thought is almost too poetic to be real. A tiny moon, in the cold, outer reaches of our solar system, hides a warm, dark ocean, and on the floor of that ocean, there are likely volcanic vents, creating a chemical soup rich with possibilities. Like Europa, this hidden sea knows nothing of the sun. Its energy comes from the gentle, rhythmic flexing of Saturn's gravity, a constant kneading that warms the moon from the inside out. We think of life needing the gentle light of a star like our sun, in a place we call the habitable zone. But these ocean worlds have taught us a different lesson. Life may not need the light. It may only need the warmth, a quiet, steady heat from within. The true habitable zone of our solar system, and perhaps of the galaxy, may be far wider and more varied than we ever dreamed. It may include countless dark, icy worlds with secret, living hearts, hidden just beneath the surface. These moons are not just places. They are ideas. They are whispers from the deep, telling us that the universe is more clever, more subtle, and more full of quiet potential than we ever imagined. And what of our own planet's companions? We think of the moon, our constant silent partner. But Earth does not travel entirely alone. Our planet's gravity is a subtle, far-reaching influence, and sometimes it gathers temporary friends. These are quasi-satellites, or ghost moons. They are not true moons locked in a simple, stable orbit like our own. They are small asteroids, often no more than a few dozen meters across, that have been gently nudged into a complex, corkscrew-like path around our planet. They orbit the sun, but in a way that is so precisely synchronized with Earth's orbit that they remain our near-constant companions for centuries, sometimes even millennia. They are not bound to Earth, but they are dancing with it. One such companion is an asteroid named Kamululawa. For at least the last century, it has been tracing a delicate, looping dance around our planet. It is so faint, and its motion so complex that it was only discovered recently. Its orbit is not a neat circle. From our perspective on Earth, it appears to slowly spiral around us, like a shy moth circling a distant flame. But it is not truly orbiting us. It is orbiting the sun, on a path so similar to our own that it can never stray too far. It is like two runners on a circular track, one on an inner lane and one on an outer, who manage to keep pace with each other for many laps. They are bound not by a rope, but by a shared rhythm. For hundreds of years, this tiny asteroid will remain our neighbor, a small, silent partner in our long journey around the sun. These companions are not permanent. The gravitational dance they perform is a delicate one, easily disturbed. Eventually, after a few more centuries, the subtle pulls of other planets will gently tug Kamawela out of its synchronized orbit. Its path will diverge from ours. It will drift away, leaving Earth's vicinity and continuing on its own solitary journey through the solar system. Our ghost moon will vanish, but others will come. The solar system is full of these small wandering bodies, and from time to time, another will be captured into a similar temporary embrace. It is a quiet reminder that nothing in the universe is truly static. Even the celestial arrangements we think of as eternal are in a state of slow, gentle flux. Our planet collects and releases these tiny temporary moons, like a traveler gathering and then losing companions on a long road. There is a strange and beautiful poetry to these objects. They are not majestic like our own moon. They are too small and distant to be seen with the naked eye. They are just faint, wandering specks of light in a telescope, easily missed, but they are a part of Earth's story. They are silent witnesses to our world, sharing our little pocket of the solar system, bathed in the same sunlight, weathering the same solar wind. We do not know their origin. Kamoloa has a composition that suggests it may be a fragment of our own moon, blasted off in an ancient impact and sent into a solar orbit, only to return millions of years later to dance with its parent system. If so, it is not a stranger at all, but a long-lost piece of our own world, a memory of a violent past returning to us as a quiet, ghostly echo. These tiny, fleeting companions remind us that even a planet can have a quiet, hidden social life, full of brief encounters and long goodbyes, written in the slow, patient language of gravity. We turn our gaze now to the center of our home, to the star that gives us warmth and life, the sun. From our quiet distance, it appears as a serene, unchanging disk of light, a constant presence in our sky. We see its surface, a roiling, turbulent ocean of plasma, dotted with the fleeting shadows of sunspots. But this is only its skin. Deep within its core, in a realm of unimaginable pressure and temperature, the sun is not silent. It is singing. It is a song not of sound, but of vibration, a deep, resonant hum that fills the entire star. Just as a bell rings with a clear, fundamental tone and a cascade of complex overtones, the sun continuously vibrates in a symphony of millions of different modes. This is the science of helioseismology, the study of sunquakes, and it allows us to hear the hidden music of our star. These vibrations are born from the chaos of the sun's interior. The sun is a great, boiling ball of gas. Enormous convection cells, currents of hot plasma larger than our own planet, rise from the depths, deliver their heat to the surface, and then cool and sink back down. This constant, churning motion, like the bubbling of a colossal pot of water, generates waves of pressure that travel down into the sun's interior. They journey through its layers, bounce off the dense core and return to the surface, their paths bent and altered by the conditions they encountered along the way. As these millions of waves interfere with one another, they create a complex pattern of resonance, a steady, humming vibration that makes the entire sun gently swell and shrink, breathing in and out over a period of about 5 minutes. We cannot see this motion directly. The oscillation is so slight that the sun's diameter changes by only a few kilometers, but we can detect it in the light. By carefully observing the Doppler shift of the light from the sun's surface, we can map these subtle rhythmic movements, and from them, reconstruct a picture of the star's unseen heart. This deep song is the sun's autobiography. Every aspect of its interior leaves an imprint on the vibrations that pass through it. The temperature, the density, the chemical composition, the speed at which different layers rotate. All of these things subtly change the speed and direction of the sound waves. By listening to this stellar music, we can build a map of the sun from the inside out. We have learned that its core rotates faster than its surface. We have mapped the great, slow rivers of plasma that flow beneath the visible photosphere. We have measured the depth of its convective zone. It is like tapping on a wall to find the studs, or using an ultrasound to see inside a living body. We are listening to the echoes from a place we can never visit, a place where the pressure is so high that atoms are stripped of their electrons, and the temperature is over 15 million degrees. In that core, every second, hundreds of millions of tons of hydrogen are fused into helium, releasing the torrent of energy that has powered our solar system for 4.5 billion years. The sun's song is the sound of its own creation, the steady, powerful hum of its nuclear furnace. And this music connects us to all stars. Our sun is not unique in its song. Most stars, it turns out, vibrate in a similar way. The field of astroseismology listens for the faint, rhythmic flickering in the light of distant stars, the signature of their own internal music. For small, sun-like stars, the song is a gentle, high-pitched hum. For great, bloated red giants, it is a deep, slow, resonant bass note, with periods lasting for days or even weeks. By listening to these stellar heartbeats, we can determine a star's age, its mass, and its evolutionary stage with a precision that was once impossible. We can tell which stars have a dense, dead helium core and which are still happily burning hydrogen. We can even trace the history of our galaxy star by star, listening to the echoes of their births. Every star in the night sky is a silent instrument, and each one is playing its own quiet, steady chord in a symphony that has been unfolding since the dawn of time. Our sun is just one voice in that great cosmic choir, a familiar melody in a universe made of light and vibration. From the deep music of the sun, we drift outward again to a realm of silence and shadow. Between the orbits of Mars and Jupiter lies the asteroid belt. The name itself conjures images from science fiction: a dense, chaotic field of tumbling rocks, a perilous graveyard where spaceships must dodge and weave through a constant barrage of debris. It seems a place of violence and claustrophobia, a barrier separating the inner rocky planets from the outer gaseous giants. But the reality, as is so often the case in the cosmos, is far quieter and far, far emptier. The asteroid belt is one of the most desolate and lonely places in the entire solar system. The truth lies in the sheer scale of space. The asteroid belt occupies an enormous volume, a vast, circular donut of space, hundreds of millions of kilometers wide. While it is true that it contains millions of objects, from dust grains to dwarf planets, the space they occupy is almost incomprehensibly vast. The average distance between any two asteroids, even small ones, is well over 1,000,000 kilometers. That is more than 3 times the distance from the Earth to the Moon. If you were to stand on the surface of an asteroid in the middle of the belt, you would not see a sky filled with tumbling rocks. You would see a sky of perfect, empty blackness. Your nearest neighbor would be so far away that it would appear as nothing more than a faint, star-like point of light, if you could see it at all. The asteroid belt is not a field of gravel. It is a desert, and the asteroids are the scattered, solitary grains of sand. This emptiness is why we can explore the outer solar system at all. Every spacecraft we have ever sent to Jupiter, Saturn, and beyond has had to pass directly through the asteroid belt. Not one of them has ever had to plot a complex, evasive course. They simply fly straight through. The probability of accidentally colliding with an asteroid, even a small one, is less than 1 in a billion. Space is simply too big, and the objects within it are too few and far between. The belt is less a barrier and more a ghostly presence, a region of space that is technically occupied, but experientially empty. It is a river of rubble, but one so wide and so slow that the water is almost entirely invisible, with only the occasional lonely piece of driftwood to mark its passage. The asteroids themselves are not just rocks, they are silent storytellers, like the comets of the Oort cloud. They are primordial remnants, leftover material from the birth of the solar system, but they are from a different neighborhood. They formed in the warmer region between Mars and Jupiter, a place where it was too warm for ice to condense as readily. They are the failed building blocks of a planet. In the early days of the solar system, the material in this region began to clump together under gravity, forming thousands of small bodies called planetesimals. Had they been left alone, they might have eventually coalesced to form a 5th rocky planet, but they were not left alone. The colossal gravitational influence of their neighbor, the newborn giant Jupiter, constantly stirred the belt. Jupiter's gravity was a great disruptive force, flinging the planetesimals into chaotic high-speed orbits, causing them to collide and shatter rather than gently merge. The asteroid belt is the beautiful scattered wreckage of a planet that never was. Each asteroid is a fragment of that lost potential. Some are solid chunks of rock and metal, the dense, heavy cores of larger bodies that were shattered in ancient collisions. Others are rubble piles, loose collections of gravel and dust, held together only by their own feeble gravity, like great floating sandcastles. They drift in the silence, tumbling slowly through space, their surfaces scarred by billions of years of smaller impacts. They have no air, no weather, no sound. They are worlds of pure, unadulterated silence, where the only event is the slow, patient crawl of sunlight across their cratered faces. They are museums of the early solar system, preserving a record of the conditions and the violence of a time long before our own world had fully formed. To visit one would be to step back in time, to stand on a piece of the original material from which all the planets, including our own, were made. It is a quiet, lonely place, a field of ghosts, a gentle reminder that for every world that is born, there are countless others that are scattered into dust. We pull our focus back now, letting the entire solar system shrink to a single point of light, a quiet star with its tiny orbiting family. From this distance, we can begin to see the neighborhood in which our sun lives. Like a house in a city, a star does not exist in isolation. It is part of a local environment, a specific street and block within the grand spiraling structure of the Milky Way. And our sun, it turns out, lives inside a bubble. Not the small bubble of its own making, the heliosphere, but a far larger, far more ancient structure. We are floating inside the hollowed-out remnant of a great and ancient violence. This is the local bubble, a vast, cavernous region of space, 1,000 light-years across, where the interstellar gas is far thinner and hotter than in the surrounding galaxy. This bubble is a ghost. It is the echo of a series of cataclysms that took place long before the first humans walked the Earth. Some 14 million years ago, our sun's path through the galaxy carried it into a dense region of star formation, a stellar nursery brimming with young, massive stars. These stars, many times larger than our sun, live fast and die young. They burn through their fuel in a blaze of glory, and then, after only a few million years, they explode. One by one, a cluster of nearby stars went supernova, each one a cataclysmic blast that sent a shockwave of unimaginable power ripping through the interstellar medium. These shockwaves, overlapping and reinforcing one another, acted like a cosmic snowplow. They scoured the region clean, blasting away the cool, dense clouds of gas and dust, leaving behind a vast, hollowed-out cavity filled with a tenuous million-degree plasma. We live inside that cavity now. Our solar system entered the local bubble about 5 million years ago, and we will continue to drift through it for several million more. It is our home, our local galactic weather. The fact that we are inside this low-density region has a profound effect on what we see. The night sky is clearer for us than it might otherwise be. The great dark curtains of interstellar dust that obscure the view in other parts of the galaxy have been swept away in our vicinity. We have a relatively clear window out into the deeper universe, a privileged view from inside the quiet eye of an ancient storm. The very beauty of the Milky Way, arching across our sky, is made more brilliant by the fact that we are looking through the cleaned-out space of this ghostly bubble. And we are not just passing through an empty space. We are breathing its air. The wisps of interstellar gas that do drift into our solar system are not the cool, dense material of a typical galactic cloud. They are the hot, thin remnants of this ancient explosion. Our heliosphere, the sun's own protective bubble, is what keeps this million-degree plasma at bay, protecting our planets from direct contact. We are a bubble within a bubble, a small sphere of calm floating inside a larger sphere of ancient fire. It is a strange and beautiful thought. The ground beneath our feet, the air we breathe, the quiet stability of our world, all of it is drifting through the heart of a scar, left by stars that died millions of years ago. We live in the aftermath, the piece of our small corner of the galaxy was born from a distant, terrible violence. The silence we experience is the silence that follows a great and thunderous roar. And what of the galaxy's heart? We have drifted through the quiet frontiers of our own home and the ghostly neighborhood around it. Now, let us take a great leap of the imagination, a journey of 26,000 light years, to the very center of the Milky Way. Here, in the dense, crowded core, lies a realm utterly alien to our quiet suburban existence. It is a place of fierce radiation, powerful magnetic fields, and a density of stars 1,000,000 times greater than in our own vicinity. The night sky there would not be black. It would be a solid blazing wall of light, a continuous overlapping glow from millions of nearby suns. And at the very heart of this luminous chaos, enshrouded in thick, swirling veils of dust and gas, lies the galaxy's central supermassive black hole, Sagittarius A*. But this place is not just a riot of light and gravity. It holds a strange, almost whimsical secret. Deep within the vast molecular clouds that orbit the galactic center, astronomers have detected a chemical signature. The heart of our galaxy, it seems, has a scent, and it smells, faintly, of raspberries and rum. This is not a fantasy. It is the result of careful, patient detective work using radio telescopes. These telescopes are designed to see the universe, not in visible light, but in the long, invisible wavelengths of radio waves. Every molecule in the universe, when it tumbles and vibrates in space, emits a faint radio signal at a very specific frequency, a unique chemical fingerprint. For decades, astronomers have been pointing their telescopes at the dense clouds near the galactic center, listening for these faint, molecular whispers. They have found a rich and complex chemistry there, a cosmic soup of over 100 different types of molecules, many of them organic. And among them, they found two in particular. One is ethyl formate, the chemical that gives raspberries their distinctive sweet smell and is also a key component in the flavor of rum. The other is Sagittarius B2, a vast, dense cloud of gas and dust, which contains billions and billions of liters of it. Imagine that vast, dark cloud, hundreds of light years across, cold and dense, a place where new stars are waiting to be born. To our eyes, it would be a black, impenetrable curtain against the bright backdrop of the galactic core. But to a radio telescope, it is a glowing, fragrant fog. It is a cosmic cocktail, mixed on a galactic scale over billions of years. The simple atoms forged in the first stars, hydrogen, carbon, oxygen, have been slowly, patiently combining in the cold, dark shelter of this cloud. Blasted by the radiation from nearby stars and stirred by shock waves, they have formed into these surprisingly complex organic structures. The galaxy, it turns out, is a chemist of extraordinary skill. In its darkest, coldest places, it is quietly building the very molecules that, on our world, we associate with sweetness, with flavor, with life. This discovery is more than just a charming curiosity. It is a profound clue about our own origins. It tells us that the building blocks of life are not rare. They are not a special feature of our own solar system. They are common. The universe seems to have a natural tendency to create chemical complexity. The very same organic molecules that form the basis of biology on Earth are being manufactured in colossal quantities in the heart of our galaxy, and indeed, in galaxies all across the universe. These molecules are then incorporated into the new stars and planetary systems that form out of these clouds. They are delivered to the surfaces of young planets by comets and asteroids, seeding them with a rich prebiotic soup. The journey from a simple molecule like ethyl formate to a living, breathing organism is still a vast and mysterious one. But the first step of that journey, the creation of the raw ingredients, is not a miracle. It is a normal, everyday process of the galaxy. The universe is not a sterile, empty place. It is a fertile one, and it has been perfuming its own clouds with the scent of raspberries for a very, very long time. It is as if the galaxy itself is dreaming of life, and in its dreams, it mixes the sweet, familiar scents of a summer garden. Let us now take one final step back, a leap so vast, it dissolves not just our sun, but our entire Milky Way galaxy into a single, shimmering point of light. We have explored our home, our neighborhood, and the heart of our own stellar city. But our city is not alone. It is part of a grander structure, a cosmic supercommunity whose shape and scale have only recently been revealed to us. The Milky Way, with its 100 billion stars and its great spiral arms, is but one of thousands of galaxies in a magnificent flowing river of stars. We are citizens of the Laniakea supercluster. The name is Hawaiian, meaning immeasurable heaven, a perfect tribute to a structure so vast it defies our sense of scale. It is our true cosmic address, a filament in a web that stretches across more than 500 million light-years of space. For most of history, we thought of galaxies as island universes, solitary, majestic spirals and ellipses drifting independently through the great dark void. But this is not the case. Galaxies are social creatures. Gravity, acting over immense distances and eons of time, has gathered them into groups and clusters. Our own Milky Way is part of the local group, a small, intimate gathering of a few dozen galaxies, dominated by our own and the great Andromeda galaxy. But this group is itself just a small suburb of a much larger metropolis. For decades, astronomers have been mapping the positions and motions of the galaxies around us. They measured not only where galaxies are, but where they are going. By observing the faint redshift or blue shift of their light, a pattern began to emerge, a picture not of random motion, but of a vast, coherent flow. It is as if the universe has a geography, a landscape of cosmic hills and valleys that are invisible to the eye. These valleys are not carved from rock, but from gravity itself. At the center of each great valley is a great attractor, a region of immense mass, a gravitational basin into which everything for hundreds of millions of light years around is slowly, inexorably falling. Our local group and every other galaxy group and cluster in our part of the universe is part of one such flow. We are all streaming, like a river of starlight, toward a single distant point in the direction of the constellations Centaurus and Hydra. Laniakea is the name we give to this entire watershed, this vast basin of attraction that contains over 100,000 galaxies, including our own. It is our home supercluster, a single dynamic entity bound together by the gentle, persistent pull of gravity. To see Laniakea is to see the quiet architecture of the universe. It is not a solid object, but a pattern of motion. Imagine releasing 100,000 tiny glowing boats onto the surface of a vast, dark ocean. At first, they might seem randomly scattered, but as you watch over an immense period of time, you would see them begin to drift, forming currents and eddies, all flowing gently toward a great, invisible whirlpool. That is what our universe looks like on the largest scales. The galaxies are the glowing boats. The space between them is the flowing water, and Laniakea is one such current. Our Milky Way is not on a solitary journey. We are part of a great, silent migration, a cosmic pilgrimage of 100,000 galaxies, all traveling together through the dark. The journey is so slow, the distances so vast, that we will never feel the motion, but it is happening. We are flowing. The ground beneath us, the sun above us, the entire galaxy around us is a droplet in a river of unimaginable scale, a river made of worlds. And where is this river flowing? It is flowing toward the heart of Laniakea, the great attractor. But even this is not the final destination. On an even larger scale, we see that Laniakea itself is just one lobe of an even larger structure, a neighboring supercluster called Perseus Pisces. And both of these great rivers of galaxies appear to be flowing toward an even more massive concentration of matter, the Shapley supercluster, the largest known gravitational basin in our local universe. It is as if we are in a small stream that flows into a river, that in turn flows into a great sea. We are part of a web of filaments and voids, a cosmic foam where galaxies are strung along glowing threads of dark matter, surrounding vast, empty bubbles of near-perfect nothingness. This is the grandest pattern of nature, a delicate, intricate lacework of gravity and matter, stretching across the entire observable universe. And we are a part of it. We are not just in a galaxy, we are in a filament, in a supercluster, in a quiet, flowing corner of the immeasurable heaven. From the grandest structures of the present, we now journey to the earliest moments of time. Let us dissolve the superclusters, the galaxies, even the stars themselves, and travel back to an era before any of them existed. Let us go to a time just after the beginning, when the entire universe was a hot, dense, opaque fog. In the first few 100,000 years after the Big Bang, the cosmos was a uniform, glowing plasma, a sea of protons, electrons, and photons, all trapped in a frantic, brilliant dance. Light could not travel freely. Every photon was instantly scattered by a free electron, its journey cut short, its message lost in the blinding chaos. The universe was full of light, but it was a light that could not be seen, a perfect, luminous fog that filled all of space. Then, as the universe expanded, it cooled, and when it cooled to a temperature of about 3,000 degrees, something remarkable happened. The protons and electrons, which had been darting about freely, finally had slowed down enough to embrace. They combined to form the first stable atoms of hydrogen. Suddenly, the fog cleared. The light was set free. The photons that had been trapped in the cosmic plasma were released, and for the first time, they could travel across the universe in a straight line, unimpeded. This moment, known as recombination, was the universe's first dawn, and the light from that dawn is still with us today. It has been traveling across the cosmos for 13.8 billion years. As the universe has expanded, this ancient light has been stretched, its wavelength elongated, its energy diluted. The brilliant, white-hot glow of the early universe has cooled to a faint, cold whisper. This is the cosmic microwave background radiation. It is the oldest light in the universe. It is an echo of the Big Bang, the afterglow of creation, and it is everywhere. It is not coming from a single direction, not from a distant star or galaxy. It is coming from every point in the sky, in every direction, with almost perfect uniformity. If your eyes could see in microwaves, the entire night sky would be softly, evenly glowing, a luminous, spherical shell surrounding us on all sides. When you look at the CMB, you are looking back in time to the very edge of the observable universe. You are seeing the infant universe, a baby picture of the cosmos at the moment it first became transparent. It is the most distant and most ancient thing we can ever hope to see, a fossil made of light, a wall of radiance that marks the boundary of our cosmic view. This faint, cold glow is not just a curiosity. It is the Rosetta Stone of cosmology. Though it is almost perfectly uniform, it is not quite imprinted upon it are tiny, almost imperceptible fluctuations in temperature, variations of just 1 part in 100,000. These are not random noise. They are the seeds of everything we see today. In the primordial fog of the early universe, some regions were infinitesimally denser than others. These denser regions had slightly stronger gravity, and as the universe expanded, they began to pull in more and more matter. Over hundreds of millions of years, these tiny primordial seeds grew into the vast structures we see now. The slightly warmer spots in the CMB map became the clusters and superclusters of galaxies. The slightly cooler spots became the great cosmic voids. Everything, from the Laniakea supercluster to our own Milky Way, from our sun to the planet we rest upon, can trace its lineage back to one of these tiny ancient fluctuations in the afterglow of creation. We are the descendants of these faint ghostly ripples in the oldest light. The entire tapestry of the modern universe was woven from these first delicate threads. The history of everything was written in a whisper, just moments after the dawn of time. Let us drift now from the oldest light to the deepest silence. We journey to the most extreme and enigmatic objects in the cosmos, to places where gravity has overwhelmed all other forces, where space and time themselves are bent to a breaking point. We go to a black hole. It is a point of infinite density, a star that has collapsed under its own weight, a bottomless well in the fabric of space-time. It is the definition of silence. It emits no light, no heat, no sound. Anything that crosses its boundary, the event horizon, can never return. It is a one-way door to nowhere, a perfect, absolute darkness. How then can we listen to something that is fundamentally silent? How can we find a voice in a place defined by its absence? The universe, in its subtlety, has provided a way. We cannot hear the black hole itself, but we can hear the space around it. For many years, astronomers have observed the Perseus cluster of galaxies, a colossal gathering of thousands of galaxies, all swimming in a vast, diffuse cloud of superheated gas. This gas, at a temperature of tens of millions of degrees, glows fiercely in X-ray light. And when astronomers looked at this cloud with the Chandra X-ray Observatory, they saw something extraordinary. They saw ripples, giant, concentric rings of brighter and dimmer X-ray emission, spreading out from the central galaxy of the cluster like ripples on the surface of a pond. These are not ripples of light, but ripples of pressure, of density. They are sound waves, propagating through the intergalactic gas on a scale almost too vast to imagine. The distance between each ripple is some 30,000 light years. These are the deepest and largest sound waves ever detected in the universe. And what is causing them? At the heart of the central galaxy in the Perseus cluster lies a supermassive black hole. This black hole is not dormant. It is actively feeding, pulling in vast quantities of gas from its surroundings. But not all of this gas falls in. As it spirals toward the event horizon, some of it is funneled by powerful magnetic fields and ejected back out in two colossal opposing jets of high-energy particles. These jets, traveling at nearly the speed of light, blast into the surrounding gas cloud, creating enormous expanding cavities. Each time the black hole sends out a pulse, it is like a great slow beat of a cosmic drum. The push of these jets creates a wave of pressure, a sound wave that travels outward through the gas for hundreds of thousands of years. The ripples are the visible evidence of this sound. This is not sound as we know it. It is a note on a scale of profound depth. If we were to translate the frequency of these waves into an audible pitch, we would find it to be a B flat, some 57 octaves below middle C. It is a note so low, so deep, that a single oscillation takes more than 10 million years to complete. It is the deepest note ever heard, a sub-bass rumble that has been echoing through the heart of a galaxy cluster for billions of years. We cannot hear it with our ears, of course. Space is a near-perfect vacuum, and sound needs a medium to travel. But the thin gas between the galaxies, a medium 100 million times less dense than the air we breathe, is enough. It is enough to carry the deep, slow heartbeat of a black hole. It is the sound of gravity itself, made audible, a quiet, persistent hum from the most silent object imaginable. This discovery changes our perception of the cosmos. We think of space as a silent, empty stage upon which the drama of light and gravity unfolds. But it is not silent. On the grandest scales, it is a resonant chamber filled with the deep, slow vibrations of its most massive inhabitants. The spaces between galaxies are not empty voids, but great, invisible oceans of thin plasma, capable of carrying the echoes of cosmic events for eons. The universe has a voice. It is a voice that speaks in a register far too low for us to hear, a language of pressure waves that take millennia to travel from crest to crest. But with the right instruments, we can see its effect. We can see the music. It is a quiet, humbling thought. The great, empty spaces are not empty. They are humming, and the song they are singing is the song of a black hole, a steady, rhythmic pulse from the deepest heart of the dark. From the deepest sound, we turn now to the quietest touch. As you rest here, in the stillness of your room, you feel as though you are separate from the universe, an observer looking out at the distant stars. But you are not separate. You are immersed in it. The cosmos is not just out there. It is flowing through you, every second of every day. In a silent, ceaseless rain, the universe passes through your body. This is a shower of neutrinos, the ghost particles of the cosmos. They are among the most fundamental and most mysterious building blocks of reality, and they are everywhere. Trillions of them, born in the heart of our sun and in the fiery depths of distant stars, are streaming through you right now. As you breathe, neutrinos are born from fire. They are created in the heart of nuclear reactions, in the very processes that make stars shine. In the core of our sun, as hydrogen atoms are fused together to create helium, vast quantities of neutrinos are released as a byproduct. They pour out of the sun's core in every direction, a constant, luminous wind of ghostly particles. Unlike light, which can take 100,000 years to zigzag its way out of the sun's dense interior, a neutrino is barely there at all. It is so light, so ethereal, and interacts so weakly with other matter that it passes through the entire sun in just 2 seconds, flying out into space at nearly the speed of light. They are messengers from the sun's deepest heart, carrying a direct, real-time report from its nuclear furnace. And their journey does not stop. They stream across the solar system, a silent, invisible torrent. In the 8 minutes it takes them to travel from the sun to the earth, they do not slow. When they arrive, they do not stop. They pass through our planet as if it were not there. They stream through the atmosphere, through the ground beneath you, through the walls of your home, and through your own body. At this very moment, 100 trillion solar neutrinos are passing through you. Every single second, they feel nothing. You feel nothing. They are ghosts. They are so unreactive that to have a 50% chance of stopping a single neutrino, you would need a lead shield more than a light year thick. They are the closest thing to nothing that is still something. And it is not just our sun that sends them. Every star in the sky is a source of neutrinos. When a massive star reaches the end of its life and collapses in on itself, triggering a supernova explosion, it releases a burst of neutrinos so intense that for a few brief seconds, it outshines the light of all the other stars in the universe combined. These neutrinos, carrying the story of a star's final violent moments, travel across the galaxy for thousands, even millions of years. Some of them, by pure chance, will end their long journey by passing through you. Even now, a few neutrinos, from a star that died long before human civilization began, are likely slipping through your resting form. Silent emissaries from an ancient cataclysm, we are bathed in the ghosts of dead stars. How do we know they are there? If they are so elusive, we build traps of extraordinary sensitivity. We go deep underground into old mines or beneath mountains to shield our experiments from all other forms of cosmic radiation. And there, we build enormous detectors, vast tanks filled with thousands of tons of ultra-pure water or liquid argon, lined with thousands of light-sensitive sensors. And we wait. We wait for the 1 in a trillion chance that a single neutrino, out of the countless trillions passing through, will happen to strike the nucleus of an atom in the detector just right. When this impossibly rare event happens, it creates a tiny, ghostly flash of blue light, a faint ethereal cone of energy called Cherenkov radiation. This is the whisper we are listening for. Each tiny flash is the footprint of a single neutrino, a ghost that has finally given up its secret. There is a profound beauty in this. It is a connection to the universe that is both intimate and immense. We think of ourselves as solid, opaque beings, bounded by our skin, but to the universe, we are almost completely transparent. We are glass. The most fundamental processes of the cosmos, the very heartbeats of the stars, flow through us without impediment, without our even noticing. We are not just looking at the universe. We are porous to it. We are soaking in it. It is a quiet, constant reminder that the boundary between ourselves and the cosmos is a gentle, permeable one. The light of the stars falls on our skin, and the ghosts of the stars pass right through our bones. We are connected, not just by gravity and by sight, but by a silent, invisible rain that has been falling since the first star ignited. And so, we arrive at our final thought. We have journeyed to the silent edges of our solar system, listened to the deep song of our sun, and felt the whisper of ghost particles passing through us. We have traced our address in the great flowing river of galaxies and looked back to the first dawn of time. Now, we make the shortest journey of all, a journey from the stars into ourselves. We return to the simple, quiet fact of your own existence, resting here in the dark, and we find that this is not a return at all. We find that the cosmos is not something you are merely in, it is something you are. You are living stardust. This is not a metaphor. It is a literal truth. Look at your hand, resting quietly beside you. Consider the gentle rise and fall of your own breathing. Every atom in your body, with the exception of the very lightest elements, was forged in a place of unimaginable violence and beauty. They were born in the heart of a star. The hydrogen atoms in the water that makes up most of your body are primordial, formed in the first few minutes after the Big Bang, the oldest matter in the universe. But everything else, every other piece of you, is a gift from the stars. The carbon that forms the backbone of your DNA, the oxygen that you draw with every breath, the iron in your blood that carries that oxygen to your cells. None of it was created on Earth. It was all created in the nuclear furnace of a star's core. Imagine a star, many times more massive than our sun, living its brilliant, fiery life in this arm of the galaxy, long before our Earth was even a thought. For millions of years, it burned, fusing lighter elements into heavier ones. In its core, it turned hydrogen into helium, helium into carbon, carbon into oxygen, on and on, building up the periodic table in concentric, onion-like layers. It was a cosmic alchemist, a factory for the raw materials of life. transforming the simple, primordial gas of the universe into the rich, complex elements that make worlds and bodies possible. The star was building you, piece by piece, in its heart 4.5 billion years ago. Then, its life came to a spectacular end. Having exhausted its fuel, the star collapsed under its own immense gravity and then rebounded in a supernova explosion, one of the most powerful events in the universe. In that single blinding moment of destruction, the star outshone the entire galaxy, and in that final fiery instant, even heavier elements were forged. The gold in the rings you might wear, the calcium in your bones. The star died, but it did not vanish. It cast its newly forged elements out into space, seeding the surrounding interstellar clouds with the precious, heavy atoms it had spent its entire life creating. It was a final, generous act of creation, a death that was also a birth. The star became a ghost, its enriched guts scattered like a fine, glittering dust through the spiral arm. And then, for a long time, there was just quiet. The enriched cloud of gas and dust drifted, cooled, and swirled in the gentle currents of the galaxy. Gravity, patient and relentless, began to gather it together again. Small clumps formed, growing denser and denser, until one of them, in the heart of this stellar nursery, collapsed under its own weight and ignited. A new star was born, our sun. And around this newborn star, a flat, spinning disk of leftover gas and dust coalesced, the same dust that had been enriched by that long-dead supernova. From this disk, the planets of our solar system formed, including a small rocky blue world, third from the sun. Our Earth, the iron from the heart of that dead star, sank to the center of our planet, creating its magnetic core. The carbon and oxygen became part of its atmosphere, its oceans, and its rocks. For billions of years, this stellar inheritance lay dormant, and then, in the warm, shallow waters of this young world, something new began. The carbon atoms, forged in a star's heart, began to link together, forming long, complex chains. The oxygen atoms, born in that same fire, bonded with hydrogen to form the water that cradled them. The iron atoms were drawn into the first simple cells, helping them to process energy. The universe, through the patient laws of chemistry and physics, began to wake up. The stardust was no longer just dust. It had become life. It began to replicate, to evolve, to feel over eons. It grew into the vast, intricate tapestry of biology that we see today, and it grew into you. The iron that pulses through your veins is the same iron that was at the core of a star. The calcium that gives your bones their strength is the residue of a cosmic explosion. You are not just made of the same stuff as stars. You are the stuff of stars, rearranged, reawakened, and given the gift of consciousness. Let this thought settle into you. As you drift towards sleep, you are not a stranger here. You are a child of the cosmos, a direct descendant of the stars. The universe is not a cold, distant, and uncaring place. It is your ancestral home. Its long, slow, and sometimes violent history is your history. Its story is written in your own body. You are a living, breathing archive of cosmic time, a temporary arrangement of ancient matter that has, for a brief, shining moment, woken up to wonder about itself. And now the time for wondering is over. The stars begin to dim behind your thoughts. You have drifted far tonight, from the silent frontiers to the dawn of time, and all the way back into the quiet miracle of your own being. You are a part of this great, unfolding story. The atoms of your body are on a long journey, and this life, this moment of rest, is just one chapter. You are borrowing them from the universe, and one day you will return them so they can continue on their journey, perhaps to become part of a new star, a distant planet, or a life form yet to be imagined. But for tonight, your journey is done. There is nothing left to do but rest. Let the vastness of these thoughts dissolve into a feeling of simple, quiet peace. You are stardust. You are ancient. You are home. Let the gentle gravity of sleep pull you down now into the soft, deep, and dreamless dark. Sleep well. Sleep deeply. The universe is breathing with you. Good night.